Okay, so we have an example that's asking us how many 7-digit numbers can you make from the set 222, 44, 79 when fours cannot be next to each other. Now, in order to solve this type of question, we want to kind of go about it in a roundabout way. The first thing we want to solve for is how many 7-digit numbers can we make with no restrictions? So number of solutions with no restrictions. The reason we want to do this is because after we find A, we are going to find the number of solutions where the fours are always next to each other. Okay, so number of solutions where fours have to be next to each other. Now the reason we're going to do this is because our solution that we're actually looking for here is the difference between two of these things. Because if you think about it, if we have our number of solutions with no restrictions, so no restrictions, minus the number of solutions where the fours have to be together, so fours next to each other, that will give us the solution where our fours are not next to each other. So solution where fours are not next to each other. So let's begin. Let's find A. So we're just trying to find the number of 7-digit numbers we can find where there's no restrictions. So of course we still have to take into account repeaters. And if you can see that we have the number of 2s we have 3 of them. So this is the element we're focusing on, and this is the number of them. So for 2s, we have 1, 2, 3 of them. So we have 3 of them. For 4s, we have 2 of them. And then 7, we only have 1, and 9, we have 1. So in order to figure out the number of solutions with no restrictions, well, we're simply just arranging 7 elements, so 7 factorial, and we just have to divide out those repeaters. So I'm going to take into account the 3 2s, so the number of ways we can arrange those 2s is 3 factorial. So I'm going to divide out that 3 factorial, and then I'm going to take into account my repeaters of 4s, so 2 factorial. And that will give us, divided by, that will give us 420 ways to arrange these 7 digits. Okay, now let's focus on B. Let's find out the number of solutions where the fours have to be next to each other. Now we've learned how to do this. What we're going to do is we're going to group the 2 4s and see them as a single element. So when doing this, we're actually only arranging 6 elements. We have 1, 2, 3, 4, 5, 6. And the pool we're choosing from, or the set we're choosing from here, is our grouped 4s, okay? And then we have the remaining values to choose from. We have 2, where we have 3 2s, we have a 7 and a 9, and we can place these throughout and make different arrangements. Now that means we are arranging 6 elements, so this is 6 factorial. Now in doing something like this, we still have to consider the repeaters. So here, we still have those 3 2s popping up. So divide by 2 factorial. Or sorry, 3 factorial. Now this is really important to understand. When we decide to group these 2 4s, we still have to consider how those 4s can be arranged with each other, and then if they're repeaters themselves. So we can multiply here, and this is taking into account this grouping, and it would be, we have 2 elements that we are arranging, but they're both identical, so we're dividing 2 factorial. So in reality, we're actually canceling these 2 things out. So at the end of the day, we are just solving for 3 factorial, or 6 factorial divided by 3 factorial. So 6 divided by 3, that is not what I wanted. And you'll get 120 possible ways to arrange these digits in a 7-digit number where the 4s are together. Now to solve for C, so to solve what we're looking for, it will be our number of no restricted arrangements minus the number of arrangements where the 4s are next to each other to solve for when the 4s are not next to each other. So C, we are going to do 420 minus 120, and that is going to give us 300 arrangements. So we have 300 7-digit numbers, 300 7-digit numbers where the 4s are not together. And of course, this is taken from our set of 2, 2, and 2, 4 and 4, and those 2 other numbers are 7 and 9. Okay, so we have 300 total arrangements.